So implementing a max heap. So this is one of the better sorting algorithms with n log n time complexity. So what we want to do is we want to sort this array right here using a max heap. So firstly, this whole process, we need to convert this into a heap. Now, what is a heap? So a heap is a complete binary tree. And what this means is that all values of a tree are filled except for potentially the last level. So let's walk through this array right here and create the heap. So 4 is the root, 6 is left, right is 3. See, we're filling from left to right. Then we go to 6. We start here and we fill with 2 and 9. So that's step 1, to create a heap, to create a complete binary tree using this array here. Now what we need to do in order to sort it is convert this into a max heap. Now a max heap is just where the root is greater than its children. So it's greater than its left child and its right child. So in this case, 4 is not greater than 6, so we need to flip those. So 6, 4, 3, 2, 9. We've also got 9 down here, which is greater than 4, so that's not a max heap yet. So we flip those two values, we put 9 there, 4 there. Is this a max heap? No, it's still not a max heap because we need to flip 9 and 6. So 9 goes here, 6 goes here, 9, 6, 4. Now this is a max heap. So we can update this array to mimic this max heap we have here. Now in order to sort the array using this max heap, we need to flip the root value with the last child node. So once we do that, we have 4, 9, and then we can update this array again to mimic that. We can have 9 in here and 4 here. I put 9 in green because that is now going to be removed from the heap. So we have one less node to worry about. And now we repeat the process. So is this a max heap? No, it's not. So we need to convert it into a max heap. So we need to flip 6 with 4. So 6 goes there, 4 goes there. Is this a max heap? Yes, it is. So what do we do now in order to sort the array? Well, we flip the root with the last child node, and then we update the array, and then we can remove this last value from this heap, reducing the size of the heap. So repeat the process. Is this a max heap? No, it's not. We need to flip this value with this value. Now is it a max heap? Yes, it is. What do we do with a max heap in order to sort the next value? Well, we flip this value with the last child node, which is the right side here. Now we update the array to mimic this. 4 has been sorted, so we can now remove it from this heap. And then we're left with 3 and 2, so we repeat the process. 3 is greater than 2, so this is a max heap. Great. So what do we do with a max heap in order to add the sorted value into the array? We flip the values, and then we update the array. Now we can remove this last value from the heap because it's now sorted. And we're left with 2. So 2 can be removed from here, and we can update the array. And then we have a sorted array using a max heap of time complexity n log n. So for this solution, we need a function called heapify. We're going to pass an array, a length, and a parent index. So the parent index is just going to be the last parent with children. So we need a reference first. So we can have the largest is equal to parent index. Because if, for example, the left child or the right child is greater than the parent index, we need to update that. So we need a reference for this parent index. So we can say left is equal to parent index times 2 plus 1. So in this example here, we have 4, 6, 3, 2, and 9. Index 1, 2, 3, and 4. So say the last parent index is 6 here, and we want to find the left child and the right child of that. So 2 is the left child, 9 is the right child. How can we work this out from this information? Well, if we say this is the parent index, we times 1 by 2 and add 1 to that. That's going to give us 2 plus 1, which is 3. So that's the left child. And then the right child is just the left plus 1. Now we need to check if the left child or the right child is greater than the value at the parent index, then we need to flip them. Okay, so we need to set the largest to the right or the largest to the left. And we need to make sure they're inbound. So if left is less than length, so if it's inbound and r left is greater than r largest, largest equals left. If right is less than length and r right is greater than r largest, largest can be set to right. Now here is where the reference comes in. So if largest does not equal parent index anymore, r at parent index, r at largest, and then we need to heapify from this largest element. So we need to recurse in order to carry this out throughout the entire tree. And then we can return r here. So that's the heapify function sorted. We also need to create a heap sort. And this is just going to take in the array. Now with the heap sort, what we're going to do is we're going to build a max heap, and then we're going to start switching the last and first value of this max heap, like we did in the example. So for this, we need length, which is equal to r.length. We need to get the last parent index. So the last parent index is equal to math.floor length divided by 2 minus 1. So what I mean by that is in this example, the last parent index is 6 because it has 2 children here. So we need to work that out. So we said it would be math.floor length divided by 2 minus 1. So length is the length of this array. So we have 5 in here. 5 divided by 2 minus 1 will give us 1.5. Then we floor it to equal 1. And that is going to give us the index of 6. If, say, for example, we had an extra here, and we add 7 in here, we have 6, so it'll be 6 divided by 2 minus 1. So that's going to be 2, and 2 is the last parent index. Okay. We also need the last child index, which is just going to be length minus 1. So in this example here, the last child index is here, and it's going to be array length, which is 5 minus 1 equal to 4. So we're going to get this index. Okay, so next we need to build the max heap. So while the last parent index is greater than or equal to 0, so as long as the last parent index is within the array, we can heapify. So we can use the function we did before and recurse, passing in our length and last parent index. Now the important thing we need to do is we need to decrement last parent index here so that we can essentially remove it from the heap. So after we've created the max heap, we need to switch the last element with the first value of the max heap. So while last child index is greater than or equal to 0, we flip those values. So we flip the first value, or the root of the array, with the value at the last child index. Then we heapify, so we create that recursive call. We pass in r, we pass in last child as the length, and we pass in 0 as the parent index. And then finally, we need to decrement last child index to essentially remove it from the heap. Finally, we can return r, and then we can give this a go. So if we console.log heap sort, and we pass in an array of 4, 6, 2, and 9, last child is not defined. Okay, so it's last child index. And there you have it. The array has been sorted using a max heap.